Hello everyone, I'm Akash. In today's video, I will discuss a question on complex analysis from recent CSIR NET June 2024 exam. Question is, if f of z is equals to 1 over z times sine of 1 over z and g of z equals to f of z times sine z, then which of the following is or are true? These are the options. So let's begin the solution. We will examine one by one each of these given options. So let's start with option 1. F has essential singularity at z equals to 0. Is this a true statement? Yes, this is a true statement. To see it, note that we can write f of z as sine of 1 over z upon z. We can write this f of z as this. And clearly this is a rational function. And we know from theory that only singularities of rational function are zeros of denominator. And clearly only 0 of denominator is z equals to 0. So this implies z equals to 0 is only singularity of f of z in complex plane C. And as this is the only singularity of f of z, so by definition of isolated singularity, this implies z equals to 0 is an isolated singularity of f of z. Okay, and hence we can write f of z as Laurent series expansion about z equals to 0, because this is an isolated singularity of f of z. So writing f of z as Laurent series expansion about z equals to 0, f of z equals to 1 over z times, we will use the Laurent series expansion of sine of 1 over z about z equals to 0, which is nothing but 1 over z minus 1 over z cube times 3 factorial plus 1 over z to the power 5 times 5 factorial minus and so on. This is a Laurent series expansion of sine of 1 over z about z equals to 0. Simplifying this, we get 1 over z square minus 1 over z to the power 4 times 3 factorial plus 1 over z to the power 6 times 5 factorial minus and so on. So this is a Laurent series expansion of f of z about z equals to 0. Okay, this is a Laurent series expansion of f of z about z equals to 0. And we know that there is a result if the inner radius of convergence of Laurent expansion of f of z about point z equals to c is 0, then okay, if the inner radius of convergence of Laurent expansion of f of z about z equals to c is 0, then z equals to c is an essential singularity of f of z if and only if the Laurent expansion of f of z about z equals to c has infinitely many terms in the principal part. Okay, so what this result says, if the inner radius of convergence of Laurent series of f of z about some point z equals to c is 0, then we can use this result, and this result is z equals to c is an essential singularity of f of z if and only if Laurent series expansion of f of z about z equals to c has infinitely many terms in principal part. Now, note that for this series, that is Laurent series expansion of f of z about z equals to 0, clearly the inner radius of convergence is 0. Inner radius of convergence of this series is 0. Why? Because inner radius of convergence of f of z, Laurent series expansion of f of z about z equals to 0 is nothing but distance of z equals to 0 to the nearest singularity of f of z. Okay, distance of z equals to 0 to the nearest singularity of f of z. But we know that z equals to 0 is only singularity of f of z. So this distance, that is distance of z equals to 0 to the nearest singularity of f of z, is nothing but 0. And this distance is nothing but inner radius of convergence. So inner radius of convergence of this Laurent series expansion about z equals to 0 is 0. And hence we can use this result. And this result is z equals to, so by this result, z equals to 0 is an essential singularity of f of z if and only if the Laurent series expansion of f of z about z equals to 0 has infinitely many terms in principal part. And clearly we can see that it has infinitely many terms in principal part. Why? Because it has infinitely many terms of the form z minus 0 to the power k, where k is negative. Okay, clearly this can be written as z to the power minus 2, that is z minus 0 to the power minus 2, z to the power minus 4, that is z minus 0 to the power minus 4. So this series has infinitely many terms in its principal part, and hence by this result z equals to 0, z equals to 0 is an essential singularity of f of z. So this implies z equals to 0 is an essential singularity of f of z. Okay, so option 1 is a true statement. As option 1 is a true, so option 2 is false, because f has essential singularity at z equals to 0, so f does not have removable singularity at z equals to 0. Okay, now let's discuss option 3. Now note that we can write g of z as g of z is equals to f of z times sin z, that is f of z times sin z. So I can write g of z as sin of 1 over z times sin z upon z. Okay, I can write g of z like this: sin of 1 over z times sin z upon z. Okay, and when you take limit z tends to 0, so limit z tends to 0, g of z is equals to limit z tends to 0 sin of 1 over z, because this limit is nothing but 1. Okay, this limit is nothing but 1, so this limit reduces to limit z tends to 0 sin of 1 over z, and clearly this limit does not exist. Okay, and so as z equals to 0 is an isolated singularity of f of z, sorry, as z equals to 0 is an isolated singularity of g of z also, and the limit z tends to 0 g of z does not exist, hence z equals to 0 is an essential singularity of g of z. Okay, this is by properties of essential, by definition of essential singularity. Okay, so the option 4 is true. Okay, and as option 4 is true, so option 3 is Wrong. Okay. So the correct answer to this question is both f and g have essential singularity at z equals to 0. Okay. So if you found this video interesting and helpful, then please like and share this video and subscribe to our YouTube channel. Thank you for watching.